All right, good morning, friends. This is physics. This is 7.3. This is just last thing we saw. Law of conservation of energy. Let you write that down. Good job. All right. Law of conservation of energy. Energy cannot be created or destroyed. In a closed system, it has to be accounted for. Is basically what this is saying. It gets transformed from, what does it say? Yeah, transformed from one form to another. From what we've been learning so far, we've got gravitational potential energy and kinetic. So those are the kind of the only two that we're going to be talking about right now. So, and I think I referenced it a fair amount yesterday. That it gets converted from one to the other. So I gave you kind of a heads up to what's happening. The example, 100 joules of electrical energy is converted in a light bulb, in like an old school light bulb. What are they called? The light bulbs that with the filament in them, that kind of are this style. I can't think of what they're called right now. But anyways, tons of heat waste. 95 joules of thermal energy and 5 joules of radiant. Energy efficient light bulbs now are much better. Thermal energy is the biggest, most common kind of waste of heat, if that makes sense. I was going to say something else. One of the most efficient heat conversions is electric to heat, because this is the most common kind of form of waste energy. Take that down. The conversion of one type of energy to another is called an energy transformation. A list of energy types can be found in Table 1, page 236. You can have a look at that. Here's just some examples. Photosynthesis, radiant energy, or the light. Sunlight, turning into chemical energy. Food for the plants. Light bulb, electrical into radiant. This would be radiant plus thermal. There's always, it's nothing's ever 100% in converting, by the way. An engine, chemical energy like gasoline into kinetic energy, movement. The more efficient the conversion, the less waste. Quantifying energy transformations. There, good. You wrote that down. Read through the phases, page 238, to see how it takes place. It's quantified and how the law of conservation holds up. This is it in a tiny little nutshell. There's examples of a diver jumping off a diving board. Potential is at its max, at its top height. Kinetic does its max right before the diver hits the water. Total mechanical energy equals Eg plus Ek. Now, at the very top, when one of these is zero, the other one will be maxed. But also what that means is the maximum potential, like, I'll write it like this, Eg1 plus Ek1 equals Eg2 plus Ek2. What that means is, like, say at the top of a jump, like for a diver, this is max, this is zero. There's no motion. And then right before they hit the water, this is zero, and this is max. So you can use one to figure out the other, is what I'm trying to get at here. This is like Eg initial equals Ek final, and vice versa. Read tutorial 1, do practice 1, I'll do practice 1, 1 to 3. Sorry, that's such a massive assignment. So big. So sad. Alright, I'm going to pause this while I set up my papers. Okay, practice on page 241. Says a 2.2 kilogram ball, so M equals 0.2, is thrown straight up from the edge of a 30-meter tall building. Thrown straight up. Okay, so the height to start, basically, I'll say H1 maybe, equals 30. At a velocity of 22 meters per second. Okay, so V1 equals 22. The ball moves up to the maximum height and then falls to the ground at the base of the building. Use the law of conservation of energy to answer the following questions. Assuming that the reference level for gravitational potential energy is ground level. All right. So it looks like, oh, we're going to have to figure out, height and acceleration, all that with, not acceleration, that's gravity. I'll write that down. A equals G equals 9.8. Anyways, I was going to say, it looks like you need to figure things out with the 5 equations, but you don't. Watch. For A, it says, what is the total energy of the ball at the start when it had a velocity of 22? Okay, total energy at the start, so EM is going to be EG plus EK. EG plus EK could say EK plus EG, the order doesn't matter. EG, MGH, EK, 1/2, mv squared. Plug in what we know. Mass is 0.2, gravity is 9.8, height is 30, plus 1/2, mass is 0.2, and the speed is 22. So, 0.2 times 9.8 times 30 is 58.8 plus 0.5 times 0.2 times 22 times 22, 48.4. So 48.4 plus 58.8 is 107.2. 107.2 with sig figs will be 110 joules. That is the total energy in the system. It's a combination of potential and kinetic. Now the thing is, this was a ball. Yeah. So a ball's thrown straight up. So you have, it says straight up and then it hits the ground. I don't know how it goes straight up and then misses the building on the way down, but who cares? So it goes up and then comes down. At the top of its height, right here, question's probably going to ask for that. Yeah. Anyways, at the top of its height, it's still going to have 110 joules. Right before it left and on its way down, the same height, 110 joules. Right here, 110. Right here, right here. It's just a combination. The higher up, the more MGH. The lower down, the more 1/2 mv squared, the more kinetic. So at the top here, it's all potential. You know, when it comes to rest, goes up, comes to rest. That means the velocity is 0, so EK is 0. 110 joules at that moment is MGH. And same down here. We can use this. That's probably what the questions are going to ask. It's going to ask what the height is. Well, you can use 110, and that equals this. Solve for height. To find out how fast this thing is going right before it hits the ground, you use this equals this and solve for speed. Anyway, look what the question says. B. Where to go? What is the velocity of the ball at maximum height? Okay, the velocity of the ball at maximum height, you know that. That equals 0. 0.0 meters per second. It's velocity. So up, down, it's 0. It doesn't matter. And then what is the maximum height of the ball? Okay, so I kind of talked through this already a little bit. So 110 equals the total mechanical energy, which equals MGH. And now we just plug in what we know. 110 equals the mass is 0.2, gravity is 9.8 times h. So actually I'm not going to use 110, I'm going to use this. Sorry, I should have said that before, because just to get a more accurate answer. So 107 divided by 0.2 times 9.8 equals h, which 107.2 107.2 divided by 0.2 equals that. divided by 9.8 equals 54.69, whatever. Height equals 55 meters when we're talking sig figs. Okay, because all the energy in the system is now wrapped up in potential. So 55 meters, that's off of the ground. Okay, so the building is 30, so it's 25 meters higher than the roof. You dig? So then, what else do we do? That's B. Now C, what's the velocity of the ball when it hits the ground? Okay, same idea. We're using 107.2 because that's the total energy in the system. 107.2 equals EK equals 1/2 mv squared. 107.2 equals 0.5 times 0.2 times v squared. So 107.2 divided by this, and then take the square root of it. So 107.2 divided by 0.2 equals that, divided by 0.5 equals that. And that makes sense. Now take the square root of that. Root of that is 32.7. Say velocity or speed? Velocity. 33 meters per second down. If it said speed, we don't need this. This is velocity, so we need a direction. And that's it. Kind of a short one today. I say there's only 3 questions. They are in a little bit involved, but it's really not too bad. Why didn't I assign 4? And that 4 is... Oh, it's like a proof. Don't worry about it. Okay, that's it. Enjoy.